I'd like to say a few things about the normal distribution. Normal distribution is fundamental to the understanding of statistics, and particularly parametric statistics. Parametric is derived from the word parameter, and the parameters of the normal distribution are things that we're very familiar with. So let's look at the formula for the probability density of the normal distribution. It's a function of observation x, a population mu, mean mu, and a population standard deviation sigma. Now, I use the word population for a very specific reason. We actually can't use the normal distribution in most of our statistics because it requires knowing the actual mu, mean, and the actual sigma, standard deviation, population standard deviation. These are unknown. God knows them, we do not. So we estimate these and we use other distributions such as the t-distribution, which is related to the normal distribution, and we'll look at that a little bit later. But if you look at this formula, and basically this formula right here represents the y-axis on this distribution right here. So we have x, the value x, and we have a y. And so when we look at this, we can really, this is not a formula we have to memorize, but you can just see there's a few familiar things in it. For example, here's our little x minus mu, the numerator in the standard deviation. And squared, it's not under the square root, so you can see this is kind of like a variance. Now it's not summed because this is for every point x. This is the height of the distribution of how many people fall underneath it, or how many observations fall below that y value. So one thing about the normal distribution is you can see it has a lot of different shapes. It's not a standard one-size-fits-all shape. In each of these cases, well, at least three of them, the mean is 0. And over here, the mean is -2. But these means are all 0. And they have different widths because their variances have different shapes. So the blue line, this one's got a narrow variance, 0.2. The red is 1. And really, this is the standard normal distribution with a mean of 0 and a variance of 1. Take the square root of that, you also got 1. And here we have 0 for a really wide slow curve. But these are all normal distributions, and your data can be if it follows a normal distribution, it can have a wide variety of x's or be more narrow. Another way we can look at it is in a cumulative distribution. So you can see that narrow blue, it starts down and it comes up very fast. So that 50% of the values cross at 0. And this is the upper 50%. And you pretty much got everybody when you get to 1 in the blue line. And in the red, you have to get a little bit over 2, 2.5, even 3. And the yellow line, you're out to 5. So these are cumulative normal distributions. Notice it has the sigmoidal shape, and that's because if you think about it, that it's not a linear increase. Values out here are less frequent than values in the middle. It's kind of like you take the values and you just kind of when the world is distributed, kind of starts piling things up in the center, but as the pile gets taller and taller, things kind of fall off to the sides, and that's the normal distribution. Now, while observations are not normally distributed, the means of samples, so we've seen before with the standard error, distributions of means, sampling distribution, where each observation, if you will, is actually a mean, that does in fact follow a standard normal distribution, assuming the n is large enough, as we've seen before. So that's the normal distribution.